Hello dear students, welcome to our video lecture. So we have discussed about optical isomerism in detail. Okay, so let's discuss a few problems. We'll be discussing here about different variety of questions through which you can understand all the concepts which are covered in this chapter. Okay. Check whether the given compound is meso or not. Okay, so dear students, in this question you have to check whether this compound is meso compound or not. Now you can think that I am using multi concepts here. Okay, first of all, this is a conformer, right? And this is actually Newman projection. If you see in detail, you can check it is eclipsed form. You remember the lectures of conformers. So this is eclipsed form. Okay. Now I have to check whether this is meso form or not. Now what I need to do? First of all, I need to draw its Fisher form. So that I can check whether it is meso or it is optically active form, right? Let me draw this compound. If I see this is front carbon, right? This front carbon COOH. I'm just drawing the structure part only, okay? And this one is having CHOH. This carbon is having HOH. Now from front carbon towards this back carbon, that is also having H and OH. Back carbon, HOH. This is your front carbon, this is your back carbon, and that is having COH. Okay. Now you can see this is actually our tartaric acid. Now, if I have to check whether it is meso or not, as we know about this structure, if this COH, if this structure resembles this part or its mirror image, both are identical. So if this represents this one, then it is a meso part. But if this H and OH are on opposite sides, then it will be optically active. So here we need to learn the conversion from Newman projection to Fisher projection. Okay. So dear students, understand one thing. Whenever you need to convert one form into another, remember the configuration must not change. Means in the given form, if it is having R configuration or it is having cis configuration, I am straightforward telling configuration means both geometrical and optical. If it is cis in one form, it must be cis in another form. Also, if it is R configuration in one form, then it should be R configuration in the other form. Clear? Now, let me convert this. Rules for interconversion. Okay, so here you need to learn a few rules. First rule is now see, rule says eclipsed form can only be drawn into Fisher form. Okay, Fisher form will be drawn for this, but this conformer must be eclipsed form. Okay, then your question might be, what we need to do if the conformer is gauge form or staggered form, something like that? Then first of all, you just need to rotate it 60 degree or 120 degree or 180 degree, no issues in that. So by rotating, keeping one part constant, means suppose you make fixed, front carbon fixed, and if you rotate the back carbon to 60 degree, just a 60 degree, okay, what you will get? You will get the eclipsed form if it is staggered, and then you have to draw the Fisher form, okay. First rule. Second, see, from front carbon, once you made the eclipsed form, what happens? Front carbon, see, suppose you are observer and you are observing from front side, something like that, then what you will see, that this hydrogen means the groups which are on your left side, left part, will be on the left in Fisher, and those which are on right side will be right side on the Fisher also. Clear? Now, if I have to draw this part only, place groups in left side on conformer, in left side only in Fisher as well. Means if you are having groups on left side in conformer, then place those groups on left side only in Fisher form. Clear? Same for right side. Remember this same case for right side also. Okay, now I hope you have understood this thing. So let me convert. So I'm just converting it. See, this front carbon, this group is upside. First you need to check the carbon chain. Okay, so just draw cross part, okay, Fisher part, vertical line and horizontal line. As you know, this is a chiral center having COH, H, OH and back carbon, and back carbon is also having COH, H, OH and front part. Okay, so two chiral center. Now keep this part. From front carbon, the group on the top will be placed at the top. Front carbon group at the top is placed at the top. Left side H, right side OH. Now again one chiral center, left side H, right side OH. Now this part, from back side the group attached is brought in the downside. Clear? Now as per as observation, what happens, as you know that in Fisher the horizontal line is towards the observer. Means if I say this is towards the observer, okay, and this vertical line is away from the observer, right? So you remember, eclipsed form is nothing but a representation of Fisher only. Okay, Fisher is by default eclipsed form only. Fisher is eclipsed form only. So its staggered form cannot be drawn. Staggered will not be converted into Fisher. Okay. So check this one, what I have drawn. Yes, it is a meso compound, right? If I check the RS configuration, I can check it very easily. This one is 1, 2, anti, right side. R, this one 1, 2. Clockwise, reverse, anti-clockwise. Now you can check, this is S. It is a meso compound, okay. So our problem is solved. So this is the way how you will convert, interconvert from one form into another. Now let me tell you the reverse case. If you are given this structure and if you have to draw the conformer, what you will do? You are having two chiral centers. This is front, this is back, okay. From front, you have to draw the eclipsed. This will be on left side, this will be on right side, and this will be at the top. See, top, left side, right side. Now this is back carbon. Again, this is left side, this is right side, and this one in front of this, back side. Clear to you all? So this is the way how you will convert one form into another. Done? Okay. Now dear students, let me give you one problem. You have to convert this one into its Fisher form and check whether it is meso or optically active, right? You have to do yourself. I am doing something else. I am just rotating it 60 degree clockwise. What you will get? CS3 at the top as it is. Rotate 60 degree clockwise. Back carbon. Okay. Keeping front part as it is, I have just rotated the back part. Now this methyl will come here, this fluorine will come here, and this hydrogen will come here. Okay, so dear students, let me draw this one and let me draw this one as well. Now you will ask, how will you draw this staggered or gauge form into Fisher form, as it is not possible? See, we have the alternate method, right? For examination purpose, competitive examination purpose, you are not having that much time that first you will convert this one into this one, then you will convert. You can directly convert this as well. Alternate method I will teach you. This one, if I have to draw two chiral centers, this front carbon is having H, F and CS3 back. So CS3 at the top, here fluorine this side, hydrogen this side, back carbon as well, fluorine this side, hydrogen this side, and back CS3 is at the down position. Okay, now let me find out RS configuration here so that you can observe this one and match it. Fluorine is highest priority 1, then this carbon is 2, so it is clockwise, reverse anti, S. Now check this one, 1, 2, anti, reverse, clockwise. As it is meso, you can also understand if it is R, then it will be S form, right? Now, let me draw this one. Now, for drawing this part, remember, all things are same. One change will be observed here. What? First, draw the Fisher. This part as it is, CS3 at the top, hydrogen this side, fluorine this side. Okay. Now, this part will be placed at the bottom. This part, okay, at the bottom, right? Now, the two remaining parts, as you are drawing staggered form into Fisher, which is not possible, so you have to interchange it. Means, this part which is in right side will be placed in left side, and this part which is in left side will be placed in right side. Okay, so now for this conformer, this is the Fisher. Now let me check, these two are same. As we know, this is just a rotating 60 degree, we have formed this. So these two are same, means these two must be same. So let me check it. How will you check? You have two category of two options possible. What? First thing is check by RS configuration. Second thing is check by even interchange. RS configuration first of all. This one. Fluorine is 1, this is 2. This is your clockwise, reverse. This is S. Now check this one. See, this was your S configuration, same. Now check this one. Fluorine is 1, and then this part is 2, this is 3. Anti-clockwise, reverse, because hydrogen in horizontal, remember. So this is S. So these two are same. Now let me tell you by making its even interchange. Upper part is as it is, H, F. Now this part, see, I have to bring this carbon CS3 part in vertical line. As we know, we have to bring the vertical line carbon chain like this. So CS3 will come here. See, so first interchange will be CS3 and F. So CS3 comes here. Okay, then second interchange, this part and this part. So fluorine will come this side, and hydrogen comes this side. Now you can match this one and that one. These two are exactly same. Okay. So dear students, in this way we can draw or interconvert from Newman projection, whether it is eclipsed or staggered, into Fisher form. Okay. Next question, you have to find RS configuration in the given compounds. Okay, this is first case. Now dear students, what happens here, as we know that this group is in wedge dash form and we have to find the RS configuration. Now here also what happens, you have the logic to check RS configuration using wedge dash form. I had already taught in earlier lectures. Now I am telling you one question. What happens if you have in the given question, you have already 3 to 4 chiral centers where each one is having wedge dash form, then what will you do? That shortcut method may be a typical task for you. Okay, so I am telling you one simple concept of interconversion. Again, telling how to convert wedge dash form into Fisher form using a simple method by observation. Okay, see, if you will observe this one, what happens? This CH3, this carbon is having hydrogen, OH, CH3 and ethyl this side in the plane itself, and what you will see that this OH is towards you, okay, this side, and this hydrogen is away from you, back side. Clear? Now here, as I have told earlier, if you have one chiral center, it is not at all a problematic case. Why? You can simply find out RS configuration, you can convert it in Fisher form as well using the earlier concept, wedge form at the top, dash at the bottom, and rest 2 remaining with respect to wedge, anti-clockwise or clockwise. That is one way, but I am dealing here with 2 or 3 such wedge dash forms in a single compound, 3 or 4 chiral centers having wedge dash. What will you do? Understand, if you place your eye in between wedge dash form as an observer, suppose it is I, okay, observer, okay, suppose you are standing like this is observer observing from this side. What you will see? You will see that these two, see from front, what I can see, this OH is towards me and hydrogen is away from me, but when observer see here, what he will find, this hydrogen and OH both are on his side only, both are towards him, but one is on the right side, one is on the left side. Okay, let me draw the Fisher vertical and horizontal cross. Now what you will do, hydrogen on the right side, OH on the left side. Okay, now and what you will see, this is upside, this is downside, CH3 upside and ET, CH2 CH3 downside. The way you are observing, you will be drawing in Fisher form. Now how to say whether this is perfect or not? It is absolutely correct. Why? Because you can see that Fisher is the representation of eclipsed, I told. Okay, now I am telling Fisher is also a representation where this horizontal part represents the groups towards you, towards the observer. Now you can see when you observe from this point, you will see both these hydrogen and OH towards the observer only, and these two V-shaped towards you and these two V-shaped away from you. Okay, so see, these two are away from you, these two are on dash form. Clear? So this is perfect. Now for clarity, let me find the RS configuration in both and check. See, OH will be 1, ethyl 2, methyl 3. It is clockwise, R configuration. Here 1, 2, 3. Anti-clockwise, but hydrogen on horizontal. So reverse, S, R. So this is also R configuration. Clear to you? See, I have told you here with a simple case to make you understand what you have to do. You have to make this dash part always when you will find 2-3 chiral centers having wedge dash. Do one thing, this dash part on the right side. Okay, sometimes what happens, dash part is not mentioned. So make dash part on the right side. Clear? Or on that side where it is mentioned or given. Okay, I am telling you with further a few more examples. Okay, so dear students, suppose you are given with this question and here you have to find the RS configuration. Now RS configuration finding in this one is little easier part. How? You can see here this wedge form is bromine, so dash will be hydrogen. You can easily find out, as you know the rule in wedge dash form when lowest parity on dash form. Okay, here also I have given you wedge form of this priority. So lowest priority group hydrogen will be on dash form, so you can easily find out. But here I am giving this example so you can correlate this one with the Fisher form by interconversion method. Okay, the method what you need to do, first of all you just do one thing, draw the remaining part, means here hydrogen in dash part, you can just draw this here, you can just make hydrogen here and hydrogen 1 will be this side. As you know, we are having two V-shaped parts. I told you in earlier question, two V-shaped, or already one V-shaped is given. So if one part is this side, obviously another part will be on this side only, right? Now this one, this bromine this side, so this hydrogen will be on this side only, although it is towards you and that is away from you, but it will be on both sides also, right? Now do one thing, draw this part 1, 2, 3, 4. Draw the Fisher part of this one first of all. This CS3 at the top, these two chiral centers and this CS3. Now remember one rule, the group, the dash group, generally it is here it is hydrogen. So you just do one thing, the dash group will be placed on the right side. Okay, so here this dash group, because if you will see here as an observer, again you will find what? So here if you are observing as an observer I, then you will find this bromine is this side and hydrogen that side. So for the observer standing here, you will see hydrogen will be that side, means right side. So hydrogen here and bromine this side. Okay, means what I said, the groups on dash, if it is on right side, place it in right side. If it is in left side, place it in left side. So in this part, you can see this was towards the observer, but this is towards away from the observer. Okay, now this hydrogen dash on this side. So here hydrogen this side and chlorine this side. Understood? I told dash group on right, so right. Dash group on left side, this side, so left. Clear? Now let me verify this conversion using RS configuration. First of all here, bromine is first priority, this part will be second. So it is clockwise, this is R. Now check this one, chlorine is 1, this part will be second priority. So this is also R configuration only. Okay, now check this one. Bromine is 1, chlorine is 2. So it is anti-clockwise, but hydrogen on horizontal, so it is R. Now check this one, chlorine, bromine here, so anti, but hydrogen here, so it is clockwise. See, both are having RR configuration, here also RR configuration. Okay, but remember this is not a meso compound. Okay, this is bromine, this is chlorine. Here you are having 4 stereoisomers, 2 to the power 2, 4. Okay, done. Let me give you one question, and in that question you have to draw the correct form. Draw the Fisher of this given question. Okay, draw by yourself. Okay, let me draw it. As you can see, I have taken three chiral centers. So top is your CS3. This will be, see, as I told, dash part this side. Just you can take observer's eye here, H that side, hydrogen this side, and here hydrogen right side. Now you can place OH here, Br here, and this Cl this side. Okay, I told you place dash group on that side which is present in the given form, which dash. So hydrogen in dash right side, hydrogen in dash left side, okay, this side, and hydrogen in dash right side, so right side. Clear? Now you can cross verify it using RS configuration. Here OH is 1, this side is 2, this is clockwise, R, Br1, this side is carbon is having chlorine, this side oxygen, so this is preferred. Anti-clockwise, S, now check this one, chlorine this side, anti-clockwise, S, you can see it is RSS, okay. Check this one, OH1, this is 2, anti-clockwise, reverse, R, bromine 1, this side is 2, clockwise, but hydrogen here, so it is S. Now check this one, chlorine 1, this side 2, clockwise, but reverse anti-clockwise, so it is also RSS, okay. So you can check the conversion can be done in this way. So dear students, I told you how to convert wedge dash form into Fisher form using observation method when you have 2 or 3 or 4 chiral centers which have been mentioned as wedge dash form, okay. Here what I used is, in all the questions I used lowest priority group on dash position, but it can be anything. You have to use the same concept here or same logic here. Why I did this? I did that so I can assure you by checking RS configuration. As you know, when lowest priority group on dash, you can check direct RS configuration by assigning 1, 2, 3 priority order. And here also I mentioned, then I just correlated the two, okay. Done? Okay. Find total number of stereoisomers in okay. So dear students, these two questions, here you have to find the total number of stereoisomers, okay. Find out by yourself first. Done? Okay. See, what happens here, if you see this is a chiral center, right? From this side, if you will go this side, this is 2 degree, this is 3 degree. This carbon is having methyl and hydrogen as well, right? So it is chiral center. Now check this one. This is also chiral center. Remember? Now you can understand that these two are chiral centers, and with this chiral center, if I use the formula 2 to the power n, 2 to the power n, what? Here 2 chiral center, 2 to the power 2, 4. See if it is possible. You are getting 4, but it is not possible. How? You can make the numbering from both sides. How you can make the numbering? You can make the numbering like, if you use the form numbering from pi bond, you have to make the numbering. So from this pi bond having pi bond plus this substituent. So from here you can make also, from here also you can make the numbering, right? From here if you make 1, 2, 3, 4, 5, 6. So you are having 3, 4 and 6. If you make from here 3, 4 and 6. So numbering can be done from two sides, both the sides. Means there must be one of the symmetrical part, okay. So remember, using the formula, you have to observe all the cases, okay. So here there must be one part meso or there must be one part symmetrical. Now let me observe. What you can do is, as you know, this part may be wedge and this part may be wedge. So if I draw its structure, see, I cannot cut this part into 2 equal halves. How? If I cut this part into 2 equal halves, then if for this one, this is the mirror image, no problem. This pi bond and this pi bond, okay. But this part and this part are not mirror image of each other, right? So this is optically active. Means one more case, its mirror image will also be counted. How? Both on dash form, okay. Now let me draw another case where one in dash and another in wedge. Now dear students, check this one. In this one, what you can observe is from this part, if you go this side methyl, this side methyl, and these two are in plane, same plane. Now from this center, this is towards you and this is backside of you. So if you move from this point towards methyl, so that part will be that part upside, exact. So this part methyl and this part, it belongs in the same line. So this part is having COS present. Okay. So we have two cases here, optically active plus mirror image, and this one. So when both on wedge, it is optically active, it's a dash form, and when one in wedge, one in dash, it is optically inactive. So you are getting total 3 cases. Okay. So total number of stereoisomers for this compound will be 3. Come to this question. Now here also, if you will see as a chiral center, what you will get from this carbon 1 2 CH3 1 2. So you won't be observing any chiral center here, right? Not possible. Now let me draw geometrical isomer. If all 3 on same side, all 3 on same side, if all 3 are on same side, you can see it is meso. How it is meso? I can cut from this ring, consider ring as a rigid, cut using this methyl. So these two are mirror image. So if you cut using any of the methyl and ring, the remaining 2 methyl will act as a mirror image part. So this is inactive, right? One case will be when you place any one group on different side, by default the remaining 2 groups on the same side. Means you place one group on one side and 2 groups on other side. Another second possibility, it is cis, in one way it is trans. So in this case also, take this methyl which is on different side, taking this dash form and this ring, you can say it is also optically inactive. So for this one, you have 2 cases only. Now dear students, what you can think, sir, all 3 on same side, 2 on same side, make 1 on same side. See, if you make 1 on same side, wedge form of this one, that same, as it is optically inactive, its mirror image will be this one in wedge, these 2 in dash. Simple, same only. So you are having 2 isomers. Okay. Okay, so dear students, it is one of the very famous question, how to find out total number of optically active and mesoforms in this one. Simply if I have to say, find the total number of stereoisomers of this compound. Okay, now check. From this COOH, it is a chiral center. How? This COH is having one COH, this carbon COH, hydrogen, this carbon is having COH, and this carbon is having pH. So this is a chiral center. Okay. This is also a chiral center. So you are having 4 chiral centers, but at the same time you can make numbering from here or you can make numbering from here. Okay. So in that way, when numbering can be done from both sides, and chiral centers, if I am telling, then 4 chiral centers, then formula n is even, you can use the formula. Here I am not using the formula, I am telling you how to draw all the cases, because when you have to draw all the cases, you will understand, you can make your imagination powerful, means how we have to consider all the cases. Suppose you are just asked, draw the mesoforms, what you will do? See, one part is, first place all the groups on same side, all on same side. all on same side. Okay, now in this case what you can find, it is a meso. Okay, second case, any one group on different side. Now in that case what happens, you have two possibilities, place either COH on different side or place PH on different side. Okay, so let me draw first COH on opposite side. In this case neither you can make COS nor you can make plane of symmetry. So in this case you can find that it is optically active. Okay, now let me draw the next case. Now I am making this PH on opposite side. Okay, rest 3 on same side. Now this is also same like this only, but here PH on opposite side, it is also active. Okay, now dear students, let me draw one case where what I am doing now, 4 on same sides, 3 on same side, two cases. Now see, this COH or this COH, it is same, right? Now two groups on same side. Okay, two groups on same side. What you can make is either make this both COH on same side, or you can make both PH on same side, or you can make this. See, when you make this COH on same side, by default this both PH on same side by default. Now first observe this one. Yes, you can cut this in this part, it is having POS, so it is inactive. Okay, now let me draw another case. Again I will do same thing, but I will make this COH and PH on same side. Okay, so dear students, here this COH and this PH, these two on same side. Now in this structure you can see from this is COH but this is PH, so no case of what? No case of COS. Also you cannot make it as POS. Why? Because this COH is away from you, this COH is towards you. Okay, so if you cut like this, it won't be the mirror image, so it is active. Okay, now there is one more possibility in which way you can place the two groups on different sides. How? Here what I did, first I did both COH on same side, then what I did, this 1-2 position, here also 1-2 position on same side. Now I am making 1-3 position on same side. This COH, this COH, okay, this PH and this PH. Now dear students, here you can see that this part, if I say this one, then in this one also, if you cut like this, it will be optically active only, right? So it is optically active. Why? Because it is not having POS, it is not having COS, so it is also active. Done. So what I did, all on same side, then first of all on same side, any one group on same side, two cases, both active. Then any two groups on same side, one case, second case, third case. Now if I say any three groups on same side, that is this one only, one group on different side, so three groups on same side, by default covered. Okay, Now let me calculate the total number of active cases and meso cases. Active 1, 2, 3, 4. 4. Meso 2. See this one and this one. Okay, as you are having 4 chiral center, these two are meso only, right? So total SI, total stereo means 4 2 8, because 4 are active, so its mirror image will also be taken. 4 2 8 plus 2, 10. Okay, so dear students, it was one of the best case to describe you how to draw all the cases. Okay, done. Let me take another question. Okay, so dear students, I told you how to draw all the stereoisomers in ring. Okay, how to consider all the cases. Now draw by yourself. Let me check. Okay, so I am starting again with the same criteria. First of all 4 on same side. Okay, all 4 on same side. In this case, what you can think, if you draw diagonally using the diagonal part, either this COH COH or this PH PH, you can observe it is a optically inactive part. Okay, so it is inactive, right? All 4 on same side. Now another case, 1 on different side. So I have two possibilities. Either I can make COH on different side or PH on different side. So I'll draw both the cases. Okay. Now in these two cases, if I have to check, see here also this PH PH on same side. So take the diagonal plane such that COH COH will be cut into equal halves. So in this way, if you cut, so these two on same side, mirror image part, so it is also optically inactive. Okay, so no need to draw its enantiomer or mirror image. Its mirror image will be what? Identical. Now again, here take the plane, this plane diagonal such that this PH PH cut into two equal halves. So it is also inactive. Now the next case will be any two on same sides. Okay, 4 on same side, 3 on same side. Now any two on same side. See, I made first of all here, I made 1 2 on same side, then I will make 1 3 on same side. Now if you see these two on same side or these two on same side, that is same only, right? This COH PH or this COH PH, that is okay. So this part if I see, then from this part you can see this PH away and this PH towards you, means if you draw a line from this which touches this, then it will surely touch this PH also. So from this it is having center of symmetry. Again from this COH and COH, it is also having center of symmetry. So it is also inactive compound. Okay, 2 on same sides. Now let me take another case. 1 2 on same side, now 1 3 on same side. Now students, you can see in this one also you take either the plane containing pH pH or COH COH. If this plane or this plane, you are having plane of symmetry in this also, so this is also inactive. Okay, so dear students, you can understand in this all four is same side inactive, one on different side means 3 on same side, 2 cases both inactive, 2 on same sides 1 2 or 1 3, either you take COH COH on dash or COH COH on wedge. As it is inactive, its mirror image will be that part, right? So it is also inactive, so its mirror image also inactive, so no need to draw. So we are having total 1 2 3 4 5. So for this compound you are having 5 stereoisomers, and out of 5 all are optically inactive, no enantiomer. Okay, so I can say total stereoisomer of this compound equals to 5. Okay, all are optically inactive. Clear? Okay, so dear students, in this case you have to find the RS configuration. Okay, how to draw? It is very easy, right? Why I am asking this question, you can understand just now. From this you are having this carbon 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 common and hydrogen, but here you are having C triple bond C, right? So first of all let me draw its hypothetical form. Okay, C triple bond CH. What I can do? C single bond CH. From this carbon you are having 2 more carbons. Okay, done. From this carbon you are having CH and 2 extra bonds, means 2 extra carbons. Now from this carbon as also this CH, 1 carbon done, but 2 more carbons. Okay, so this group is nothing but this group in hypothetical manner. Now check this one, this carbon and this carbon, this carbon and this carbon. Now this carbon is having 2 methyl, this is also having 2 methyl, and this is having CH 2 methyl, CH 2 methyl. Now here the question arises, what you will do? One by hypothetical method comes like this, and the same part is very similar to this part also. Okay, so in that case you are having a diplomatic case. Do one thing, real is preferred over virtual. Real is preferred over virtual. Okay, so dear students, what you will do? You will just make this part as priority 1 and this part as priority 2. This is 3 and this is 4. Okay, now this is anti-clockwise S, but hydrogen here, so it is R configuration. Done. So this was also one of the important concept. Real is preferred. If you are having hypothetical bond breaking, then remember, if on hypothetical bond breaking the group comes and the already present group both are same, then real is preferred. Okay, done. Cis 1,4-bis tertiary butyl cyclohexane. So dear students, for this compound you have to draw its most stable conformer or its most stable structure. Okay. Now let me draw first of all cyclohexane. 1,4-bis, bis means 2 times and cis means same side. Tertiary butyl. Tertiary butyl simply means CMe3 and 1,4. So 1, 2, 3, 4. CMe3. Okay. So dear students, as we know that for cyclohexane we have different types of conformers. You remember? Okay. And you also remember its most stable form was chair form. Okay. Chair form, then your twist board, then your half chair. Remember? Okay. Inverted chair was also there. So all these cases. Now let me check which can be the most possible case. First of all, let me try with chair form. See, this part was, if you remember, this part was 1 CMe3 on downside to make it equatorial, because bulky group most lie at equatorial position. So 1, 2, 3, 4. Okay. Now this must be also on downside because it is said cis form. So to draw cis form, you must make both CMe3 tertiary butyl, base means 2 times and cis for same side. So this is down, this is down. Now this is down, up. See, if you have made hydrogen upside, this is equatorial, so this is axial, this is equatorial. So here we are having problem. Why? One CMe3 bulky group on equatorial but other on axial position. So this is incorrect. Okay. This is not the most stable form. Now let me check another case. See, if I take both on same side, in this form, if I take both CMe3, 1, 4 means 1, 2, 3, 4, both CMe3 on same side, also it will be problematic, it will not be more stable. This was our half chair. As we know, this is the most stable form, so it is useless to draw this form of cyclohexane, right? Also, if I say 1, 2, 3, 4, as this is in itself unstable, so we need not to draw this. So one more possibility we have is if you remember this in 3D diagram, remember this is this part towards us. Okay, you remember this part is towards you, towards us in 3 dimension. Now if you see 1, 2, 3, then this is 4. As we have this on same side, so if I make this CMe3 downside and hydrogen upside, here also it will be this side, CMe3 downside and hydrogen like this. Yes, this is the best possible case. So this is our twist boat form. Okay, so dear students, for this cis 1,4-bis tertiary butyl cyclohexane, twist boat form is the best possible or most stable form. Understand? This is the reason why we teach all these 4 cases. Why? Because if you remember all the cases in this boat form, that 1,4 diols was stable, okay, due to this attraction part in 1,4 OH. In twist boat, this is stable. Generally, chair form is stable, and this is not at all stable. Done. Okay. So I think you have understood this question. This is one of the best possible case, especially for competition examinations, advanced level question. Okay. So dear students, here we discussed about various cases, about different type of problems, how to solve it, about especially about total number of stereoisomers in ring structures, and about real versus virtual, also about interconvergence. Okay, so I hope you will like these all cases and you will solve the problems easily now. Okay, we will continue on next lecture.